Hi, in this video I'll be testing a modified servo with an Arduino board. This servo has been modified to rotate continuously instead of the regular 180 degree rotation. I connected the servo to the Arduino according to this schematic, which has a separate battery power supply and also utilizes a breadboard just for ease of connection with no soldering. If you need a more detailed explanation on how to connect the servo to the Arduino in this manner, check out the link at the end of this video, which is entitled Set Servo to the Neutral Position using Arduino. Instead of using a potentiometer, I will just use some simple code to control the speed and direction of the modified servo. The code will allow me to adjust the speed and direction of the servo based on the input received from the serial monitor. Let's take a look at the code. As you can see, the code includes the servo library, which is required in order to control the servo. We then create an instance of the servo class, myServo, and then define some variables, all integers, the first one being servo pin, which I've initiated to 9. And I've got two delay variables. The first delay variable is servo delay, which I've set to 100 milliseconds. It just lightens the load on the servo itself. Then we have buffer delay, which I've set to 3000 milliseconds, which is, well, 3 seconds. Now that's just to allow the input buffer to clear properly. The next variable I've set is servo speed, and I've initiated it to 0, so anyone can understand that 0 is obviously the stationary position, stopped. The next variable is servo value offset, which has been initiated to 90. So although the speed might be 0, the servo itself requires the value of 90 to be at the stationary position. And the next variable I have here is adjust val, which just means the adjustment value. In other words, how big a step the change will be. Please note that the stationary position for the modified servo is the former neutral position of the servo when it was in its non-modified state. Writing the value 90 to the servo causes the modified servo to neither rotate counterclockwise nor clockwise. In other words, it remains at the stationary position, as I've just mentioned. If, however, you find that your servo is rotating slowly in either direction, this can be corrected with the Arduino code that I'll demonstrate in this video. The reason why I'm using the variable servo value offset is for two reasons. The first reason being, well, from a common sense perspective, when the speed value is 0, the user would normally expect the servo to be stationary. However, the servo requires the value of 90 to become stationary. Hence, an offset value of 90 can do that job without confusing the user. The second reason is that if the servo rotates slowly, either clockwise or counterclockwise, upon receiving the value 90, which is supposed to be the stationary position, then you'll need to adjust the servo. Such an adjustment can be taken up by the variable servo value offset. In the loop function, we check if there's any input available from the serial monitor, and if there is, we read the input and check if it is L or R, which represents moving the servo to the left or counterclockwise or right clockwise. In addition, if the serial monitor receives an input T, then it will prompt the user to enter an adjustment value between 1 and 20. We use the parseInt function to read the user's input and update the adjust value variable accordingly, and we also make sure that the adjustment value is within the acceptable range of 1 to 20. Now let's test it out. Okay, the value of servo speed has changed from 0 to -1, and the servo is moving slowly, as you can see, in the counterclockwise direction. And now the servo speed has returned back to 0 and is stationary again. Okay, the value of servo speed has changed from 0 to 1 this time. The servo is now moving slowly in the clockwise direction. And there the speed has returned back to 0 and is stationary again. Now, if your servo rotates a little bit at speed 0, you will need to counteract that rotation by changing the value of 0 value offset, which has been initialized at 90, but you'll need to know how much to change it by, and you can do that quite easily with this code. For example, if your servo is slowly rotating counterclockwise at speed 0 but stops when the speed is set to 1, the variable zero value offset needs to be set to 90 plus 1, which is 91. If your servo is slowly rotating clockwise at speed 0 but stops when the speed is set to -1, the variable zero value offset needs to be set to 90 minus 1, which is 89. So with the servo stopped at speed 0, I'll enter L a few times in succession. That has moved to the speed of -5 all at once. And then let's just adjust the speed increments. So let's adjust T to the value 5. Okay, then I'll enter L 5 times in succession. As you can see, the counterclockwise rotation of the servo is a lot faster now. I think we're at its maximum counterclockwise speed. I'll just set it to -40 and to -50, and I think you can tell that the counterclockwise rotation hasn't sped up any more than what it was at -30. Okay, now I'll just input R a number of times. Okay, so now it's stopped. And I'll just carry on inputting R to rotate the servo in the clockwise direction this time. Okay, there we go. But I think we're at its maximum clockwise speed this time. So we're at 30, and so I think it's at its maximum speed, just like -30 was its maximum speed counterclockwise. But I'll just set it to 40. And then 50, so I'll just drop it back down to 0 and stop. As you can see, the servo is moving as expected based on the input we provide. With the ability to adjust the stationary position and also the speed and direction of the servo, we can customize its behavior to fit our specific needs. To find out how I modified my servo, click here. If you have any questions or comments, feel free to leave them below. Thanks for watching.